Okay, guys, good morning. Today is the second online class, and because I record this class, we will speak English, because you're all, not all, but anyway, you're international students, and we should record it in English, but this is only for this week, because everything is changing very fast. So let's start our second class. You don't have a task on your Dropbox file file holder, so I will tell you task and we will solve it. Please, if you have any questions or when I ask something, please speak in your microphone. Turn on your microphone and answer or ask questions, because it's very hard for me to look into chat each time. Okay, let's start. Do you hear me? Everything okay?
Yes.
Okay, thanks. So today we will speak about non-linear pricing, about price discrimination, and about monopsony. Three parts. First part is about monopoly and monopsony, about vertical structure. Our first problem. It's class 2. Is about. We have many competitive identical firms, so with market supply, let's write down. Many competitive identical firms market supply, not individual, but market supply is inverse function Q divided by 2. Then we have one big supermarket that buys rice from these farmers, from these firms.
Alina, can you please write a bit with a bit bigger letters, because I can't see them.
Okay. One large supermarket that buys this rice and then sells it to consumers. And market demand from these consumers is market demand simple linear function. So our first task to find out the price that our supermarket will give to our identical firms, will pay to our firms. This will be price for sellers of rice and price that our large supermarket will give to our consumers. So price for our consumers will be price of demand. What about the structure of this market? We have vertical structure. We have a lot of farmers, small farmers, competitive farmers that sell their rice with price PS to a supermarket, and supermarket with price for buyers sells it to many consumers. How we can name this step of our vertical structure? This market is what? How we can name? With a lot of sellers and only one buyer.
Monopsony.
Yes, this is monopsony. And our supermarket has market power. That's why our supermarket, as monopsonist, controls market supply. Yes, controls market supply. Market supply, by definition, is minimum willingness to sell. You know this. It is the minimal price that small firms are willing to sell their product, by definition. So monopsony controls this market supply. Then this step: one large seller, one large supermarket, and many consumers. It's simple, it's monopoly. One seller, many buyers. And in this situation, we know that supermarket has also market power and controls the demand, the maximum willingness to pay from consumers. Controls market demand. So when our task is to find out prices that supermarket will pay to farmers and will charge for consumers, what we should do? We should maximize the profit of our supermarket. Let's write down its profit. Profit of supermarket. Now that profit is simple, it's revenue minus cost. So revenue he gets from selling to consumers. Yes, total revenue is price multiplied by quantity, and price is what?
1 minus Q.
Yes, it's not constant because we have market power, our supermarket. So it will be the inverse demand function, as was our previous class. Total revenue minus total cost. Total cost, we pay for price to our farmers. Yes, so we pay them price, PS multiplied by quantity. This is our total cost, no fixed costs. But this price is not constant for our supermarket because he controls the supply. Yes, because he has market power. So it will be not constant, but the inverse supply. He will pay the minimum willingness to sell. This is from monopsony, cost structure from monopsony, total revenue structure from monopoly. And this we will maximize by quantity greater or equal to 0. So let's write down from our type. One minus Q multiplied by Q minus Q divided by 2 multiplied by Q. This will be Q minus Q squared minus Q squared divided by 2. This will maximize by Q greater or equal to 0. We can say that this is the graph is parabola, branches down, and we can find point that will give us maximum profit, or we can write down first order condition, second order condition, and then shutdown condition. Okay, let's write down first order condition. This will be a first derivative from our profit should be equal to 0 for quantity, for interior solution, for quantity greater than 0. It will be 1 minus 2q minus 4 equal to 0. From here, q star optimal quantity that supermarket will buy and sell will be 1/3. And this is actually greater than 0, so we work in interior solution. We should not check corner solutions. Okay, second order condition, second derivative should be less or equal to 0 for maximum. And this is true, minus 3 less than 0. You should check first order condition, second order condition, and shutdown condition in each task, in each problem. Even if they are very simple. Shutdown condition, price should be greater or equal to average variable cost. Average variable cost we know. It's total cost without fixed costs divided by quantity. This is actually inverse supply here, yes? And price, we don't know the price. Let's find the monopoly prices and then check the shutdown condition. Monopoly prices. What price supermarket will pay to farmers? He wants to pay minimal price, yes, because because this price is supermarket's costs. So it will be the inverse supply out of optimal quantity that supermarket produce, and it will be q divided by 2, 1/3 divided by 2, 1/6. And he wants to have from his buyers the maximum willingness to pay. So the price that a supermarket will charge for buyers will be 1 minus q star, and it is 1 minus 1/3, 2/3. Great. So we can check shutdown condition. Here in shutdown, here what is the price? The price for sellers or for consumers?
For consumers.
For consumers, sure, because it comes from revenue. Yes. So here PD, and we can check that indeed price for consumers 2/3 greater than price for sellers. Yes. Then 1/6, and shutdown condition holds. Okay, let's write down 2/3 greater than 1/6. That means shutdown holds. Shutdown hold. Shutdown okay. This was the first step, first point. Let's do the second. In the second task, we have such situation A, B. In the second task, our supermarket has option. What option it has? Supermarket can acquire all rice farmers. What that means? Supermarket can buy all these farmers and produce rice by himself. And he can acquire all rice farmers at a fixed price, K. And produced by itself. let's write down produce rice in-house at cost. If we don't have farmers and produce by ourselves, we will have cost function, total cost function, and it will be q squared divided by 4. And our questions. For what k it will be profitable for supermarket to buy all rice farmers? Supermarket will do it.
Excuse me. Is cost function is equal to q squared over 4 or over 2?
Over 4.
Okay.
For what case supermarket will acquire farmers, will buy farmers, and for what case it is profitable, not profitable, but
Reasonable.
reasonable, yes. For what case it is, no, not reasonable, not reasonable.
It's reasonable for rice farmers to leave the market.
For what case all society will gain from such consolidation?
Welfare.
Can all society gain from such consolidation? And if society can gain from this acquiring, then we should find minimal subsidy to incentivize the supermarket to do it. Find minimal subsidy to incentivize supermarket. So, how we should do these steps?
K must be K must be more than profit of rice farmers in order for them to leave the market.
What
Why?
we know about the profit of rice farmers? They are very, very small. Yes. They are very, very small, and they are on competitive market without fixed costs. So our small firms, our small farmers will have zero profit because we work on perfect competitive market for them. And this we know from theory. Yes. For what K our supermarket will buy farmers? When it is profitable for supermarket. So we should compare profit when she did not buy farmers and profit when she
So we don't consider that rice farmers like want to leave or don't want to leave. We just considering the monopolies point of view, or what?
Again, profit of one small rice farmer is zero. Why? Because he's very, very small, and he's price taker. One small farmer, yes, he's price taker, and his price is equal to marginal costs.
Okay.
So marginal costs are cost for one unit, and price is his marginal revenue for one unit, and they are the same. So the price, the profit margin is 0 for each unit that he sells. So the price for rice farmers, because we don't have fixed cost here, is 0 as per competition. More interesting is what about the profit of a big supermarket. Let's count the profit when he
I don't see. Excuse me, I don't see the text at the top of the desk. What? Price?
Profit of rice farmers is 0 as they are perfect competitive firms. It's from theory, we know this. What about profit of our supermarket? In case when he does not acquire. Profit is equal to what? Let's count. Price when it's from point A. From point A, price was 2/3, yes. 2/3 multiplied by 1/3 minus price for farmers was 1/6, yes, multiplied by 1/3. And this is how much? 1/6. When second option, when our supermarket will acquire our farmers, he will produce rice by himself with such costs. So we should maximize such profit. When acquire, profit of supermarket will be demand, inverse demand function, because he's monopolist, multiplied by quantity, minus new costs, because we don't have upward step in our vertical structure anymore. Minus C. This is Q squared divided by 4. This we should maximize by quantity.
I guess you forgot the part with K, like minus K fixed costs.
We can write that this is a variable profit without this cost, but okay, yes, minus K as constant, yes. Sure. First order condition. Marginal revenue 1 minus 2Q is equal to marginal cost Q divided by 2. From here we find that Q star, optimal quantity to sell in such situation is 2 divided by 5. It is greater than 0, so it is okay. We work with interior solution. We should not check corner solution. Then price that monopolist will charge. We should put our quantity into inverse demand function. This will be 3 divided by 5. Yes. We should check second order condition, shutdown condition, but now we don't have time. So we write SOC and shutdown. Okay, check by yourself. Check at home. And then what we do? We write down profit. Profit when our supermarket acquire farmers. This will be how much? Price multiplied by quantity, this is revenue, 3 divided by 5 multiplied by 2 divided by 5, minus total cost. Total cost is Q squared divided by 4. So 2 divided by 5 in square divided by 4 and minus K. Yes? And this will be 1 divided by 5 minus K. So, what conclusion we can say? So, it is profitable to acquire farmers when this profit is greater than that profit. Yes, profitable to acquire farmers if profit when acquired greater or equal to profit when not, and this will be 1 divided by 5 minus k greater or equal to 1 divided by 6. And from here we can say that this price, this k, this fee should be less or equal to 1 divided by 30. This is the answer for the first point.
Excuse me, Polina, does it matter if its k is just less than 1 divided to 30, or k is less and or equal? It's matter.
It doesn't matter because when k is equal to 1 divided by 30, he is indifferent. Yes, supermarket is indifferent. So he can buy or cannot buy. Yes, but he can buy with some probability. So we write that less or equal. Okay.
Okay, thank you.
Then the second question is about society. What we know about society? What we should compare? When when society gain from such consolidation. When we speak about society, we speak about social welfare and compare social welfare in different situations. Social welfare is what? We should sum up surpluses of each economic agent that is in the market right now. What economic agents we have? We have consumers, buyers, and their surplus is consumer surplus plus surplus of producers. Yes, producer surplus. What producers we have? We have supermarket and farmers. Yes, and the surplus of these firms is profit of these firms. We know this. Yes, this is profit of supermarket plus profit of farmers. But what we know about profit of farmers? They are perfectly competitive, so their profit is 0. So we can write down that this is consumer surplus plus profit of supermarket. About profit of supermarket in 2 situations, we know everything. Yes, we counted it. But what about consumer surplus? How we can find it? We know if we will draw the sketch, this is the demand, and for some optimal price, for first unit, when we want to buy first unit, we are willing to buy it for very, very big price, but we buy it for optimal price. So this is our gain, this difference, and we can say it about all units that we buy. So the area under inverse demand function and upper than optimal price is consumer surplus. So, and we can count it as integral from 0 to optimal quantity, inverse demand function. This is the trapeze area, yes, but minus this part, and it is optimal price. So difference between maximum willingness to pay and actual price that we pay. And this we should sum up by quantity that we buy. So this will be how much? 1 minus Q minus P star from 0 to Q star. And this is Q minus Q squared divided by 2 minus P star as constant multiplied by quantity from 0 to optimal quantity. So the consumer surplus, when supermarket decided not to acquire farmers, will be how much? Quantity here was 1 divided by 3. Yes, 1/3. 1/3 minus 1/3 squared divided by 2 minus price here was 2/3 multiplied by 1/3. And this is how much? 1 divided by 18. 1 divided by 18.
Тут пару человек вылетело, можете их, пожалуйста, добавить?
Consumer surplus when we acquire farmers, the optimal quantity that consumers will buy and price changed. So this will be quantity is 2 divided by 5. Yes, 2 divided by 5 minus 2 divided by 5 squared divided by 2 minus price was 3 divided by 5 multiplied by 2 divided by 5, and it will be 2 divided by 25. So social welfare in different situations. Social welfare when we acquire, when we not acquire. This is consumer surplus 1 divided by 18 plus profit of supermarket when he decided not to acquire farmers, and it was 1 divided by 6. In total, it is 2 divided by 9. Social welfare when we decided to acquire farmers is 2 divided by 25 consumer surplus plus profit. Profit was 1 divided by 5 minus K. Yes? So this will be 7 divided by 25 minus K, and we should compare how we can answer our question. So society will gain from consolidation when social welfare is larger than in other situations. So society will gain from acquiring if social welfare when acquired greater or equal than social welfare when not. And this will be 2 divided 7 divided by 25 minus K greater or equal than 2 divided by 9. From here, we can say that this fee should be less or equal to 13 divided by 225.
Don't clean, please. I had some technical issues. 1 minute, please.
So let's check the logic. If this fee is not very big, so if this fee is very small, it is optimal for supermarket and for society to acquire farmers. Yes. If this fee is not so big but not so small, for supermarket it's not profitable, but for society it's profitable. And in this situation, we should subsidize to incentivize our supermarket. So let's look. If we write such enrollment here, k axis, here will be 1 divided by 30. Here, how much? 13 divided by 225. So here's 0. If this fee is very small, between 0 and 1 divided by 30, it is optimal for supermarket and for society to acquire firms. Supermarket plus society. If this fee is not so small but not so big, between 1 divided by 30 and this number, it is optimal only for society to acquire. Only society wants to acquire. And if this fee very big, nobody wants farmers to acquire. So when we should say about subsidy. What we should say? If fee is very small, should we subsidize? Should we subsidize? If fee between 0 and 1 divided by 30. No, we can subsidize, but our question is about minimal subsidy. And if a supermarket wants by himself to buy these farmers, so why we should give him a subsidy? Yes, as government. So here, subsidy should be equal to 0. Here, our supermarket does not want to buy farmers. So we should, but society wants. So government should give him subsidies, should subsidize. What will be the minimal subsidy? Let's count net profit. Net profit. What that means? Net profit of supermarket. This that means his gain or loss from buying these farmers. Net profit of our supermarket will be profit if he will acquire minus profit if he will not acquire, and it will be 1 divided by 30 minus k. We counted it. Net profit, gain. Gain, if it is less than 0, it is loss, yes? If it is greater than 0, it is gain. So, in this part, here, it is gain or loss, greater than 0 net profit or less than 0 here?
Less than.
Less than 0, yes? So, what we should do? What subsidy we should give? Minimal subsidy. such that this net profit will be
0.
this minimal subsidy. So minimal subsidy should be how much? For 1 divided by 30 minus k.
130. 1 divided by 30. No?
How much? For this to be 0. How to make from this 0? We should do minus 1 divided by 13. Here is 0 and minus k plus k. Yes, to be 0. So this will be k minus 1 divided by 13. This is minimal subsidy. When we subsidize, give this number to our firm, his net profit or gain will be 0. So firm supermarket will be indifferent to buy farmers or not to buy. But this is with minimal subsidy. If subsidy will be bigger, so he will definitely buy farmers. So, but our question is about minimal subsidy. And if our
I don't understand how we define minimal subsidy.
Minimal subsidy?
Yes.
So,
How to?
what we know about supermarket? When this is, we counted his gain from buying from buying farmers. So, if k less than 130, this net profit, this gain is positive, yes? 1 divided by 30 minus something less than 130. But if k greater than 130, and we are here, this is not gain but loss. This gain is less than 0. So that's why our firm, our supermarket, does not want to buy, yes, farmers in this situation. But we should, as government, we should incentivize our supermarket to do it. How we should incentivize? We should give subsidy. And our task is to find minimal subsidy. Minimal subsidy. How to incentivize? His gain should be non-negative. Yes. So minimal subsidy will be such that this net profit is 0. Minimal such that net profit is 0. So not gain, not loss. If subsidy will be bigger, so it will be gain, and supermarket will want to buy subsidy. One more time.
No, thank you. I understood.
You can. And when a fee is very big, nobody wants nobody wants farmers to be acquired. So here, minimal subsidy is what?
K minus 1 divided by 30, the same?
No, not the same. Nobody wants farmers to be acquired. So we should not want to incentivize supermarket to do it. So we will not give him subsidy. Yes, subsidy will be 0. Here also. So these 3 situations. This situation, here 0. Here, minimal subsidy k minus 1 divided by 30 to make net profit 0, at least 0. And if fee is very big, nobody wants, so subsidy is also 0.
It's like if nobody wants, just don't make them do that. Like that?
Sure.
Okay.
Yes. We can subsidize, but for what? Why? We don't want to do it. Yes, this was the first task, and we don't have a lot of time, so we should move forward and let's write down the second task. In the second task, we will speak about non-linear pricing. What was in the lecture? When buyers
The second degree discrimination.
Something like that, yes. Different non-linear pricing, different situations, yes. It can be a second degree price discrimination, but not. Let's see. Second problem. What we see? We have one single consumer with demand. Demand 1 minus Q, and quantity is between 0 and 1. So our consumer can purchase Q between 0 and 1 units for tariff as function from quantity. It was in the lecture. Nothing is clear, but great. But you can, nothing is clear, but very interesting. You can, I will make recording. Now I'm making recording of this video, and you can rewatch it to understand. Okay, units for this tariff. And our task to find quantity that our consumer will be willing to purchase and optimal tariff for firm that it will charge. Who charge the tariff? The firm that sells product. Who will buy? This single consumer. So, and also we can assume that costs are equal to 0. This assume. And we will speak about many different we have many different situations. I will write down them all, and who is fast, you can do it by yourself. I will write down all points. First, it is fixed fee when our tariff is equal to constant. When quantity is not equal to 0. B, linear pricing, standard linear pricing. Our tariff is price multiplied by quantity. C, this is in C, two-part tariff. It is like second degree price discrimination. It will be tariff is equal to fixed fee, entry fee, plus price multiplied by quantity. And entry fee only if quantity is not equal to 0. D, tariff is equal to how much? It was about quantity discount. This tariff is minimum from quantity or 1/2 multiplied by price. And if it is convex pricing, tariff is P multiplied by Q squared divided by 2. So you can solve it by yourself. You asked about from where we can rewatch this seminar. If you want to rewatch this seminar, you should write to me and explain why you should do it, why you did not attend offline or online class, as I wrote I wrote very big email to all students about this. You can write to me and I will send you the link to this seminar. Okay. What about our steps? Who plays first, firm or consumer? First, the firm charge optimal tariff, and then consumer buys. Yes. So our steps. First, firm charge optimal tariff, and second step, our consumer buys optimal quantity. So this is how in life, yes. But how firm choose optimal tariff? The firm understands how much consumer will buy for each variant of tariff. Yes? So the firm understands how consumer will behave himself, how much he will buy for different variants of tariff. So how we will solve such task? We will solve it from the end. First of all, we will find the optimal behavior of consumer, and then we will choose optimal tariff. This is from game theory. This is backward induction, or from mathematics. We will use backward induction to begin from the end. How to solve? Begin from the end. Backward induction. So first of all, we should choose the behavior of consumer. We should choose optimal quantity. How consumer decides how much to buy?
By utility function and budget constraints.
Sure. Consumer maximizes its utility. Yes. So what will be in its utility? Consumer. The utility of consumer will be. It's like consumer surplus. It's definitely consumer surplus. Yes. But how we should count it? It will be the area under our inverse demand function, as always, but minus how much it will pay, minus this tariff. So it will be integral from 0 to optimal, no, from quantity inverse demand, here Q, minus optimal, not optimal, minus tariff. This will be Q minus Q squared divided by 2 minus this tariff. And consumers should maximize it by quantity, greater equal to 0. Let's do it. In A. When we have to pay fixed amount for each quantity, how you think from intuition how much we will buy if we should pay fixed amount, fixed sum of money?
Not less than that fixed money.
How much will I ask about quantity? How much we will buy if we should pay for each amount? This for whole amount we should pay fixed price. fixed fee.
Maybe one.
Sure,
Because-
one maximum. The
Simple.
maximum, how much we will, how much maximum amount that we can buy. Sure. Let's prove it. The utility. 4 minus squared divided by 2 minus constant is fixed fee. We maximize by quantity greater or equal to 0. First order condition. First derivative out of utility should be equal to 0 for interior solution. This will be 1 minus, this is our demand, the first one, minus 0, as this is constant for us, should be equal to 0. From here, quantity is equal to 1, sure, maximum quantity. It is greater than 0, so okay, it is interior solution. Second order condition, we know, our second derivative, less than 0, check, minus 1, less than 0, okay. And something like shutdown for our consumer is what? Consumer compares what utility will be if he will not buy this product, and the utility if he will buy. So two utilities, utility from 0 and utility when he will buy something. So let's compare. If quantity equal to 0, so utility equal to what? To 0 also. Why? Because we pay fixed fee only if we buy something. And if quantity equal to 1, the utility will be how much? 1 minus
No.
1 minus 1 divided by 2 minus this t. This will 1 minus 1 divided by 2 minus t. This is 1 divided by 2 minus t. So our optimal behavior as consumer. I will buy quantity 1 only if my utility is bigger than 0. It is when 1 divided by 2 minus t greater or equal to 0. If this fixed fee is not so big, less or equal to 1/2. And I will buy 0 otherwise. So this optimal behavior, this optimal strategy of consumer knows our firm that charge optimal tariff. So now what we say about profit of firm. Profit of firm will be this tariff only if our consumer will buy something, and our consumer will buy something only if tariff less or equal to 1/2. So if tariff less or equal to 1/2, and the profit of the firm will be 0, nothing will be sold if tariff greater than 1/2, or otherwise. You can write down otherwise. So what will be the optimal tariff? What will be the maximum fixed fee that will give us maximum profit?
1 divided by 2.
Sure, 1 divided by 2, this is maximum tariff, and that gives us maximum profit. So this is the logic, and we should write down this logic for all such tariffs. Let's do one more, or for example, let's do C. I want to do C. At what time? 12:30. Yes. So let's do C. C, you know, it is two-part tariff, second-degree price discrimination. Two-part tariff. Tariff is entry fee plus price multiplied by quantity. So to have opportunity to buy the product, you should first to pay entry fee, and then when you paid entry fee fixed amount, you can buy some quantity of this product. You now have this option for some price per unit price. This is entry fee. What we can say about our consumer? Let's write down his utility and maximize. Q minus Q squared divided by 2 minus entry fee minus price multiplied by quantity. And this we should maximize by quantity greater or equal to 0. First order condition, 1 minus Q minus price equal to 0. From here we see that we speak about simple demand, 1 minus P, because this entry fee is constant. It is from first order condition. You should check by yourself second order condition. It's always okay. Let's move on. Okay, and what we can say. First of all, this quantity should be greater than 0, greater or equal to 0. So this is true only for price less or equal to 1. You see, yes? Then, when it is more useful for us, reasonable to buy some amount. When our utility from doing this is greater than the utility when we do not buy anything. So we should compare. Utility, if we don't buy anything, is 0. Utility, if our quantity is 1 minus P, is, let's write down, 1 minus P minus 1 minus P squared divided by 2 minus this entry fee minus P multiplied by 1 minus P. And this is 1 minus P squared divided by 2 minus tariff. So it will be optimal for me to buy some amount, only this utility greater or equal to 0. And this is true if our entry fee is not so big. Let's write down. So our demand, optimal behavior of consumer is to buy 1 minus price only if price less or equal to 1 and our entry fee less or equal to 1 minus P squared divided by 2. And 1 minus P squared divided by 2, it is area under inverse demand function. You can check it. This is the consumer surplus. And we should buy 0 only if price otherwise. Okay. Then what profit our firm will gain? Our profit is tariff plus price multiplied by 1 minus P, only this quantity, optimal quantity, only if price less or equal to 1 and entry fee is not so big. That's equal to 1 minus p squared divided by 2. And we will gain 0 otherwise. So we should maximize this profit. When firm choose its optimal tariff, she choose fixed fee, this entry fee, and price, 2 things. So let's write down profit is fixed fee plus p 1 minus p, maximize by price between 0 and 1, and tariff less or equal to 1 minus p squared divided by 2. So this is the profit maximization task for our firm. So, what I can say about fixed fee? If this is our upward border, if this is maximum fixed fee, I will charge this maximum fixed fee because I want more profit, I want more money. I want to take all surplus from my consumers because I can do it. Maximum entry fee is exactly equal to 1 minus p squared divided by 2. And this is exactly the surplus. So the profit of our firm we can rewrite as 1 minus p squared divided by 2 plus price multiplied by 1 minus p. And this we should now maximize by price between 0 and 1. What I can see in this profit of our firm? I can see that this is revenue of, no, I will not write down. This is revenue or profit of simple linear pricing situation. Yes, price multiplied by quantity as demand. This is the profit of the firm. And this part is consumer surplus. You know that consumer surplus plus profit as producer surplus gives us social welfare. So in two-part tariff in such situation, our firm maximizes social welfare. So what will be the answer? What will be the optimal quantity? Who can tell me?
The firm gets everything. The whole welfare.
Yes, the whole welfare. And what will be the price and what will be the quantity from intuition if it maximizes welfare, social welfare?
Price 1 and quantity 1.
Quantity 1 and price 0. Yes? Yes. Let's check it. Let's check. Minus 1 minus p plus 1 minus 2p should be equal to 0. And from here, what you see, minus 1 plus p plus 1 minus 2p is equal to 0. From here, we see that optimal price is 0 from first order condition. We should check second order condition. Okay, you can check it at home. And what is next? Price equal to 0, quantity will be equal to 1, yes, and optimal tariff will be fixed fee. Fixed fee is 1 minus p squared divided by 2. This will be 1/2 plus 0 multiplied by 1. So it will be only 1/2. And this, if we'll draw the sketch, here is demand 1/1, quantity price. Use how we can understand that it is true, what we found. Let's suppose that price is bigger than 0. So our firm will charge such price, consumer will buy such quantity, and our firm will take as entry fee all consumer surplus of our consumer. Yes, that's entry fee, maximum entry fee. But and this plus P multiplied by quantity plus this will be the profit of our firm. Yes, entry fee plus revenue, price multiplied by quantity. But this is not maximum profit. I can make my profit bigger. I can decrease the price up to 0 and gain all this triangle. Yes? To make entry fee as all this triangle, no revenue, but this is the situation that will give us maximum profit. You can also read it in every textbook. Okay, this was the second task. The third task. The third task is not very long. I hope. Third task, problem 3, is about third-degree price discrimination. We have, let's see. We have n consumers. I from 1 to n. Each consumer has its individual demand. The I out of P individual demand is AI as constant, 1 minus P, such that each individual has different constants from 0 in 1 less than 8n. Different constants. So different individual demands. We have one large firm. We know that total cost function is C multiplied by Q. C less than 1. Simple. First task. We should find price. We should find monopoly price, as we have only one large firm and many consumers. We should find monopoly price and how much each individual will buy if our firm cannot discriminate. So it will be single price for each consumer. Single price. P star as single price. No discrimination in this point. And how much each consumer will buy in equilibrium. So it's simple. What controls our large firm? Our large firm controls not individual demand but market demand. So our first step to find market demand. Yes, to sum up all individual demands. So first, market demand. Our D out of P, it is the sum from I equal to 1 to n. We should sum up individual demands. What it will be? 1 minus P is the same. We should sum up all these constants. A, I. It will be sum of I equal to 1 to n. In I multiplied by 1 minus this. Multiplied by 1 minus price. And for not to write always this sum, let's rename it as A without index. Rename. So our market demand is A multiplied by 1 minus B. From here we can write down inverse market demand. What it will be 1 minus quantity divided by A. Also then first order condition, marginal revenue equal to marginal cost. Marginal revenue is 1 minus Q divided by A divided by Q prime. This will be 1 minus 2Q divided by A. And you know it, for linear demand function, marginal revenue has 2 times bigger slope than inverse demand. Here 1, here 2. This is true for linear demand function. Then marginal cost, simple, it's only C. Yes. So first the condition. Marginal revenue equal to marginal cost. 1 minus 2Q divided by A equal to C. From here we can say that our total quantity that we will sell will be equal to 1 minus A, 1 minus C divided by 2. Yes. And price that we will charge, single price, optimal price, we should put this quantity into inverse market demand function. PD out of Q. It will be A multiplied by 1 minus, oh no, sorry. 1 minus A, 1 minus C divided by 2A. And this is 1 plus C divided by 2. This is price. So this was the first point, point A. What about point B? In point B, our monopolist can discriminate, can use third degree price discrimination. Third degree price discrimination. What that means? That means that our monopolist can charge each individual consumer its own price. So it will be individual price for each consumer. We should find it, and we should find how much each individual consumer will buy. In previous task, how much individual consumer will buy. We should put this price into his demand. It will be AI 1 minus 1 plus C divided by 2. This will be AI 1 minus C divided by 2. So here. Okay, let's talk about third-degree price discrimination. If I can charge each individual its own price, so I will maximize profit, different profits. I will maximize profits from each individual and maximize the sum of these profits. How we can write it? No, we'll not write it. So I will choose, in such situation, I will choose different quantities and different prices for each individual. So I can maximize profit from only one individual. And then say that it is true for each individual because they are symmetrically similar. Let's write down. Profit from individual I of our firm is its individual inverse demand function out of Qi multiplied by Qi minus cost C multiplied by Qi. And our big profit will be the sum from I equal to 1 to n of these profits. This will be the sum from I equal to 1 to n. And I should maximize for each quantity I greater or equal to 0. So we can maximize them. We can maximize not the sum, but only one profit, and then write down that this is true for each profit. Так.
Excuse me, can we finish the next seminar because our seminar is over and we have a lecture after that?
You can finish by yourself. I will finish.
But will you send the record?
If you write to me again, if you will write to me, please send me the link to the recording, because blah blah blah. I will send it to you. Okay. So profit will be how much? Inverse demand. Inverse demand from here. Okay, it will be like in previous 1 minus I divided by A multiplied by I minus C. Minus C is max by I greater or equal to 0. You can check that our calculations will be the same as in point A, but here we write I, here we write AI. Only a constant is different. So from here, margin revenue for individual is equal to marginal cost. And from here, we will see that quantity that will buy each individual will be AI 1 minus C divided by 2. Price for each individual will be AI star for each individual will be. We should put this quantity into inverse demand individual function. Will be 1 minus I star divided by A, and this will be 1 plus C divided by 2. And we can see that this answer is the same as in previous point. So in this task, we see that even if firm discriminate, she will get the same profit. She will get the same profit. Yes. let's write down our conclusions. But this is only in this example. So there can be such situation that that third degree price discrimination will not give us more profit. There can be such situations. Let's write down conclusions. So everything same as in A. That's why profit the same. So consumers also indifferent, and it might be that price discrimination is pointless. When can be such situation? Because in standard situations, third degree price discrimination gives us maximum profit that we can get if we can do this third degree price discrimination. Right, whenever. When marginal costs are close to constant, when marginal costs are close to constant, if we have nonlinear total cost, it's not the point. B. Consumers are sufficiently similar. You see that we definitely have similar consumers, yes? Consumers are sufficiently similar. Such that the demand of one consumer from one price divided by the demand of other consumer divided by or out of some price is approximately equal to the demand of the same consumer from other price divided by the demand of consumer G from the other price. And this is true for each different prices and for each individual. In our task, these 2 points was okay. If we have very different demands, if we have non-linear total costs, so marginal costs are not constant, so we can see that third degree price discrimination will give us more profit. But we see that there are examples when price discrimination is pointless. Okay, that's all. Thank you. Questions, please.
No questions.
Okay, so
Полина, здравствуйте. Можно, пожалуйста, вас уточнить, а возможно ли такой вариант проведения семинаров, что вы будете включать демонстрацию экрана и там, например, в блокноте где-то писать, потому что доски не видно и качество портится?
у меня нет планшета, я не буду этим заниматься, я пишу на доске. Не знаю, мы пересматривали с Красиковым, с лектором семинары и пришли к выводу, что записанное качество нормальное, все видно. Вот, все. Потому что я заканчиваю, ну, то есть у меня как сейчас семинары проходят. Давайте я сейчас пока остановлю запись.